Let me again consider the positive part, not really the positive part this time. Okay, so let's consider 6 pi from the right to the left. 5 pi over 6. 5 pi over 6 in the range. Yeah, okay. 5 pi over 6 is approximately 2.62. And then here is 2. And then 2 points, let's calculate to see exactly what's going on down here. 2 pi 5 pi over 6. Yeah, this is the picture. Yeah. Pi over, here is 0, pi over 2, 7 pi over 12, 2 pi over 3. Yeah, this one. This one we may not need to consider. 2.62 is undefined. Okay, and here is 2.5. Okay, and then 2.6 is right here or somewhere. Here, 2.1, 2, 3, 4, 5. So 2.6, 2 somewhere here. So this is actually the asymptote. This place. Okay? So we may not consider this one. Now, 2 pi divided by 3 is 2.09. Here is 2.0, and 2.09 is like 2.1. So this is the point for 2 pi over 3x. Y is 2 times radical 3 is 3.46. Here is 3, and then 3.46 is roughly this tall, because here is 3.5. We put 3.5 here. So 3.46 is slightly lower. So you have a x, you have a y, then you have a point. Okay? And then, you may consider this one. Let me consider this one. Pi over 2. Pi over 2 is 3 pi over 6. Pi over 2 is 1.57. Here is 1.5, so 1.57 is right here. Okay? And you have a value for tangent 2 times x minus 3, that's 2 over radical 3. 2 over radical 3 is approximately 1.15. 1 is here, 1.15 is about here. Okay, so this tall. So you have this point. Okay, again you can consider this one yourself. You need to check that. And pi x equals pi over 3. You have a 0. Okay, yeah. All the points on the x-axis with y-coordinate 0. So you have that. That's the x-intercept. Okay. For another 3 points on the left, here, I will choose, which one I didn't choose? 1, 2, 3. Yeah. And here, I may choose this one to consider. Okay? You may choose the other 2. Alright? Yeah. So, here pi over 12 pi over 12 is approximately how many? You see we have it right here. Or you can also use a calculator. Okay? You can also use a calculator. You see down here we have a pi, second pi divided by 12. Heat length is 0.26 something. Okay? Yeah. It's 0.26 something. So you may put 0.26 right here. And then you have a value for y is -2. Okay? So you then have a y is -2. And here pi over 12 again is 0.26 something. Yeah, 0.26 something right here. Okay? So down here is 0.1, 0.2, 0.3, so 0.62 is roughly here. You have y is -2. Okay? And then you can connect all the points together using a smooth line. That will be this picture. Okay. The thing is that right now you can see tangent x previously starting with 0. Now the x-intercept is pi over 3. The reason we have a pi over 3 as a new x-intercept is because here is pi over 3. Okay? So that's why we say this pi over 3 minus is shift the picture 3 units to the right. Yeah. You may write that. So where I should write? Probably I should write, yeah, I may write on this graph. Here is pi over 3 units to the right. Shifting is like this. Okay? Okay, what does this 2 play? These 2, originally you have all those special values. Radical 3 negative, and then -1, -1 or radical 3, all those things. For tang x minus pi over 3. Now you times each value by 2 because there is a 2 right there. So basically, if it's -1, you times +2 is more negative. Goes down deeper. If you have a +1, previously you times 2, it goes even higher. So are the cases for radical 3 and for negative radical 3. Okay, you see radical 3, 2 times radical 3, previously was radical 3, and then you times 2, so make the points higher for the same x. Okay, and here you times 2 positive, it was negative, so that's -2 radical 3, so even deeper, lower. Then we say this 2 is elongate. The graph in vertical direction. In vertical direction. Okay. So that's basically what it says. This is minus, you shift 3 units, pi over 3 units to the right. Okay. And here 2 is elongate. Here there are a couple of things you may want to think about it. If here were plus, then you will do is you shift the picture instead of to the right, it's going to be to the left. Okay? And then here, if it's -2, what is going to happen? You see, previously it was negative radical 3. U times 2, you have a still negative. If here were negative hit on another negative, you got a positive. Okay? So instead of point, previously you have a x equals 0. Okay, you have a negative radical 2 over 3. That's down here. That's y-intercept. Okay? Okay. And then if here were negative, then negative times negative radical 3, this point is going to be up. Okay? And previously, for the 2 radical 3, if here were negative, and here positive radical 3 is going to be negative 2 radical 3. So this point is going to be down. Okay, down, below the x-axis. So the picture, if here were negative, that would be like this. Yeah. If here were negative, then the picture would be something like this. Okay, that's the thing you want to think about it. Now, here there are more things you got to think. Yeah, I already talked about this part. You see, think yourself, y equals negative. What would happen? Now, another case is that 2 tangent x minus pi over 3 plus 1. What does this mean, the plus 1? What does 1 come to play in this picture? You see, without 1, that's what we get here. If every value plus 1, because there is a plus 1 down here, then the picture basically would be this one. You plus 1 to every y, because here previously was y equals that. If here were 1, then you would add 1 to each value on y. So basically this picture will be 1 unit up. Okay? So that's the picture for this one. So we did this one, and then we considered, let yourself consider these two cases. Okay? And here there are some details. Why did I choose those points? Is I did in the opposite way. Okay? They actually solve the equations. You probably want to follow this pattern. Alright? Remember, here down in front of x, we don't have we have a coefficient of 1. So here you see the picture like this, and x starts with negative pi over 6 asymptote to the positive 5 pi over 6. So what is the range from here to here? From here to here, you see the difference the distance between those two is what? 5 pi over 6 minus this value, negative pi over 6. That's the distance between those 2 points. And then you know positive negative comes to be positive. 5 pi over 6 plus pi over 6. And there is a 1 here. So 5 plus 1 is 6. And that's pi, because you can cancel that. So this is 1 period. Okay, so if here is 1, the period is not going to change. If here were not 1, then that would be different. If here were 2, how you are going to do that? comparing to sine and comparing to the next example I will show you, you probably will be able to figure out. Okay, so that's the end of this lecture for y equals 2 times tanh x minus pi over 3. I'll see you in next lecture.